As our population continues to age, we're facing an unprecedented rise in cognitive decline and neurodegenerative diseases. This creates an urgent need for effective, accessible preventative interventions. Omega-3 fatty acids, including EPA and DHA, and ALA, have emerged as promising candidates, showing neurological benefits through anti-inflammatory effects, membrane stabilization, and neurotransmitter modulation. However, there's a critical gap in our current understanding. We know marine-derived omega-3s provide preformed EPA and DHA, while plant-derived sources contain ALA that requires enzymatic conversion within our bodies, but we don't know how these sources compare directly in real-world cognitive outcomes. Our target population consists of middle to late-aged adults experiencing memory complaints, representing a unique opportunity to test omega-3 effectiveness before significant neurodegeneration occurs. Our research question addresses this critical knowledge gap directly. In adults aged 45 to 75 years old with subjective memory complaints and measurable cognitive decline, how does daily supplementation with 2 grams of marine-derived omega-3 fatty acids compare to 2 grams of plant-based alpha-linolenic acid and placebo in affecting cognitive performance, brain function, neuroinflammation biomarkers, and serum fatty acid profiles over a 12-month intervention period? This question is clinically relevant because conversion rates of ALA to EPA and DHA vary dramatically among individuals, ranging from 0.2% to 21% for EPA and 0.05% to 9% for DHA, potentially creating significant differences in cognitive outcomes. Our literature review reveals several key insights that inform our study design. Dial's comprehensive research demonstrates that EPA and DHA provide both independent and shared neurological effects. DHA primarily supports structural brain integrity, while EPA provides anti-inflammatory protection. Yassine's work with APOE E4 carriers revealed that omega-3 effectiveness depends on individual genetic factors and disease stage, with better results occurring during preclinical stages before significant neurodegeneration occurs. Most importantly, Walker's direct comparison of flaxseed oil versus fish oil in older adults showed that while both supplements increase plasma omega-3 levels, only marine-derived omega-3 fatty acids improved processing speed and cognitive performance over 6 months. Finally, Barcello and Murphy's review highlighted that ALA conversion rates vary significantly by age and gender, with younger women showing higher conversion rates and longer intervention periods potentially yielding better results. These findings collectively support our hypothesis that marine-derived omega-3s may provide superior cognitive benefits, but direct comparison data remains limited. We designed a rigorous 3-arm, double-blind, placebo-controlled randomized clinical trial to establish causal relationships between omega-3 interventions and cognitive outcomes. Participants will be randomly assigned using computer-generated sequences with stratification by age and baseline cognitive scores to ensure balanced groups. Our double-blind design ensures neither participants nor researchers know group assignments during data collection, minimizing bias. Group 1 receives 2 grams daily of marine-derived omega-3s containing EPA and DHA in standardized gelatin capsules. Group 2 receives 2 grams daily of plant-based ALA from flaxseed oil in identical appearing capsules. And finally, Group 3 receives placebo capsules containing vegetable oil with identical appearance, taste, and odor. The 12-month intervention period allows sufficient time for omega-3 incorporation into neural tissues and observable cognitive changes with monthly supplement supplies and pill counts, ensuring adherence monitoring. Data collection occurs at 3 time points during this study, at baseline, 6 months, and 12 months, allowing detection of both early and sustained changes. This diagram illustrates what we're trying to prevent, the transition from healthy brain tissue on the left to deceased brain tissue on the right. In healthy brains, neurons maintain proper connections through intact myelin sheaths and functioning oligodendrocytes. However, in cognitive decline, we see neuronal cell death, demyelination, and microglial activation and increased inflammatory cytokines like IL-6 and TNF-alpha, exactly the biomarkers we're going to be measuring in the study. Our primary outcome measures include the Ray Auditory Verbal Learning Test for memory assessment and the Trail Making Test for executive function and general overall processing speed. Secondary measures target these inflammatory processes through IL-6, TNF-alpha, and CRP biomarkers, plus serum fatty acid profiles and self-reported questionnaires. We're aiming to recruit 240 participants aged 45 to 75 with memory concerns, expecting omega-3 interventions to help maintain the healthy brain state shown here, rather than progressing towards the neuroinflammatory cascade depicted on the right. Our statistical analysis plan employs descriptive statistics to summarize baseline characteristics using means and standard deviations for variables such as age, cognitive scores, and inflammatory biomarkers. The primary analysis uses repeated measures ANOVA to compare how cognitive and neurological performance changes across the three groups over time. We'll examine within subject changes and between group differences with statistical significance set at p less than 0.05 and meaningful effect sizes will be calculated. This approach will directly answer our research question by identifying whether marine-based omega-3s show statistically and clinically significant advantages over plant-based alternatives and placebo. Secondary analysis will explore correlations between serum fatty acid profiles and cognitive outcomes, plus potential moderating effects of age, gender, and baseline cognitive status. Our study has several key strengths and limitations. Major strengths include being the first direct head-to-head comparison of marine versus plant-based omega-3 sources in cognitive health using a rigorous randomized control trial design with adequate statistical power. We're examining multiple outcome domains, cognitive performance, inflammation, and fatty acid profiles in a clinically relevant population experiencing actual memory complaints. However, important limitations do exist. Our single 12-month timeframe may not capture longer-term effects, and we're not assessing genetic factors like FADS gene polymorphisms that influence ALA conversion efficiency. External validity may be limited to our specific population of adults aged 45 to 75 with mild cognitive concerns. Additionally, maintaining participant adherence over 12 months presents challenges despite our monitoring systems. This study also cannot account for individual dietary omega-3 intake variations or lifestyle factors that might influence outcomes. Finally, our focus on subjective memory complaints may not translate to populations with more advanced cognitive decline. Based on the existing literature, we anticipate marine-derived omega-3s will demonstrate superior cognitive benefits compared to plant-based ALA and, of course, the placebo, particularly in memory strength and processing speed measures. We also expect greater reductions in inflammatory markers with marine-based supplementation. These findings will provide crucial evidence for clinical practice guidelines and public health recommendations, helping clarify whether more expensive marine-based omega-3s offer meaningful advantages over accessible plant-based alternatives. Future research should investigate optimal dosing strategies, examine genetic factors influencing ALA conversion efficiency, and explore longer intervention periods to determine sustained effects. Additional studies should include diverse populations, investigate combination therapies, and examine omega-3 interventions across different stages of cognitive decline. Understanding the economic implications of these interventions will also be critical for healthcare policy decisions. Ultimately, this research contributes to the growing evidence base for nutritional interventions in cognitive health, potentially offering an accessible, low-risk strategy for maintaining cognitive function in our aging population.